Hi there, welcome back to the DevOL. I am Roman and this is the sixth and already last episode of our event sourcing do-it-yourself video series. In the last episode, we have written our first couple of tests for our new event source system. And in the end of the last episode, I was asking the question, but what about my aggregates? So what are we going to do if we are actually handling multiple ice cream trucks, or if we are going to grow our little company and have to somehow manage different things except for ice cream trucks? So let's dive just right into this topic right now. So without further ado, los geht's. So after we have introduced events and event store projections, the behavior and some testing, I was asking the question, where are my aggregates? So again, we want to actually manage different ice cream trucks. Our small little company grows a bit and we have more ice cream trucks, and we actually want to know which ice cream truck we've just restocked, or for which ice cream truck we've sold a specific flavor. And this is what we're going to model in our new application. So let's do this. So if we think about how to actually model different aggregates in our system, we have actually different possibilities in there. We could put the information about which aggregate we are actually talking at the moment. So in our example, about which ice cream truck we are talking, we could put those into the payload of an event. So for example, in the flavor sold event, we could say that we're not only wrapping the flavor in there, but also the aggregate. Another possibility would be to introduce some metadata for our events. So we don't have the information in our events, but in some metadata that we are also storing in our event stream. But there is also a different possibility, and this is the possibility that I have chosen for this video series. So we do not store the information about which aggregate this event or specific event is about, but we are going to store this information within our event stream, so within our event store. So what does this mean? It means that we don't have one event stream anymore. We have multiple event streams in our event store. So for each aggregate, for each ice cream truck in our scenario, we have one event stream in our event store. So how does this look like then? So this is our old event store, and in here we see no information about different aggregates at all. And this is what we're going to change now. So we scratch this. We're not going to implement a whole new event store, but we add some information into our new event store. We see that we define a new type alias called aggregate, and this is an alias just for a UUID or for a GUID. So all of our entities or aggregates in our system are actually identified by a specific UUID. And what we are doing now is that we are not only asking our event store, for example, to evolve, but we also add the information which aggregate we wanted to evolve. So if you have a look at the evolve function down there, you see that we added another parameter to the function, which is the aggregate that we want to evolve actually. And then you see that we added a new function in there, which is the get stream function. And this is necessary because the get function still should return the whole event stream. So all of the events out of the event store. And you see there that we are not returning a list anymore, but we are returning a map from an aggregate, so from a UUID or GUID to a list of events. So each aggregate gets its own list of events. So I think this is enough for the introduction. Let's implement this together. All right, so we are back in our little program. And as always, let's start with the API first. So the nice thing when we are going to put the aggregate into the event stream is that we do not need to change our tests, because those tests and our domain especially do not know nothing about an event stream. So as you see, we'll see in the end, we won't change anything in our domain at all. And so we won't change our domain tests at all. But what we want to actually have is two different trucks. And there we use the system GUID and we say new GUID. so that we get two different trucks. And then what we want to actually do is we want to call the evolve function for a specific truck. So we want to say truck 1 in here. So we've entered the truck 1 in here, and of course this is not working now, but this is what we're going to implement soon. And then later on, we want to, for example, say here that we get the events for truck 1, and therefore we need a getStream function that we are going to give the truck 1 as an input. And then we also need a truck 2 events, and we're also going to call these getStream functions in there. So let's implement this first, and in the end, have a look at our helper functions to actually have a nice output. So we need to change our event store. So let's go directly up to our event store, and there we need to define a new type, and this type is an aggregate. And this is just the type alias for a GUID that is provided for us by the .NET framework. All right, then we need to change our append and our evolve functions, because now we want to actually append events for a specific aggregate. And we want to evolve our event store for a specific aggregate. And then we can actually implement a new function called getStream. And this function also takes an aggregate and returns the list of the events, so the history of the events for this specific aggregate. And the function that we actually need to change up here is the get function, because we don't have an event list anymore. And I think a nice thing what we could use as a data structure is again a map in here. So the map would be a map or a dictionary from an aggregate to a list of events. So each aggregate gets its own event stream and gets its own history. So we can change this here and say we return a map from aggregate to an event list. So now that we have done this, we of course need to fix our agent, because this whole thing here down here is not working anymore. We are missing a complete function, and we actually need to change these functions here as well. So let's just start with fixing our messages. So up here we have our 3 possible messages for our agent, and each of those messages here are specific now for a specific aggregate. So if we have the append message, we want to actually append an event list for a specific aggregate. And for the evolve function, this is the same. So we want to evolve the event store for a specific aggregate. The get one is a bit different, because the get one is returning the whole event list, so the whole total history of my event store. So the total history is not a list anymore, but it is a map, and it's a map from an aggregate to an event list. And this is what we are returning when we call get. And now we also need to actually implement this new getStream message, and this of course also gets an aggregate, and it returns a list of events, because for a specific aggregate we only return a list of events. And of course now we need to fix our implementation here for our event stream. So the first thing we need to change now is that the history is not a list anymore, because it's a map that we have just described up here. So it's a map from aggregate to an event list. So in here we start with map.empty. And now in here we need to actually adjust all our code to work with a map. So for example here we get a tuple in our message. So we get an aggregate and a list of events. And what we are doing now is, first of all, we need to find all the events of a specific aggregate. So we can call this stream events in here. And then we could take our history, which is a map, and we could try to find the key, which is the given aggregate. And when we have done this, we get back an optional value again. So this is again the try find function from the last episode. And we get back an optional value. And the default value, so if it's not in there, if we didn't put any events for this aggregate in the event store yet, we can just return an empty list. This is what we're going to do. We say option default value, and we return an empty list. So the stream event is now a list of those events. And what we need to do now is we need to define a new state, new history, and we use again the map.add function, which actually replaces the value within the map if it's already there, and if it's not there, it just adds this to the map. So we can say map add, and the key is the given aggregate, and the value is the stream events that we got earlier concatenated with the new events. And then in the end, we can just return the new history and recall our recursive function in here. So now we have changed our append function here, or our append message handling here, so that it uses our new data structure, which is a map from an aggregate to an event list, and it actually appends the new events into the right place within our new data structure. And this is what we need to do now for the rest of the message handling in here. So the get is not changed at all, because we still want to actually retrieve the whole event history for all of the aggregates. So let's create a new case here for the get stream, and in here we also get the aggregate and the reply channel, and in here we could actually use this function here to get also all the events from the event stream. And because I think we use this a lot, we could actually refactor this out a bit, put this maybe up here, and we need to put the aggregate in there and the current history. Get rid of those. And we have this new function that actually takes our history and returns the value or an empty list if it's not found. So we can use the same thing here, and we can also now use this here, reply, and in here we can just reply with the history, so with the list for a given aggregate. And of course, in the end, we should actually return our async object and call our loop function again with the current state. Nice. So the last thing we actually need to change is the evolve function, but I think after all our changes now, this shouldn't be too hard. So we have our new events in here, and we not only getting the event producer, but we're also getting the aggregate in here, for which we should evolve our event store. And then we could just use our new function that we have just created up there. So we can pretty much copy paste all of this code in here, use this here as well. And we have the stream events that we are going to use now for our event producer. And we can actually copy paste this here as well and put this down here. One more time, our implementation for the message handling. So the append function gets an aggregate and handles also the aggregate. So we are great. So now that we have done this, I think we need to fix those functions down here as well. Yes, because in here the append function gets an aggregate, and we are not using a tupled function here because the API is much nicer than down there in the program. But we can actually tuple this here for our message. We can leave the get as it is. Then we can actually change as well our evolve function in here. And the last bit that is missing is our getStream function. So let's write this real quick. So our getStream also gets an aggregate, and now we need to write it a bit differently. We also need to use the post and reply method of our agent. But now, because the reply channel is actually filled in by the agent into this function that is provided for the post and reply method. And if you have a look at here, this getDU case is also a function. It's a constructor that constructs this message type. So this get function here is a function that actually takes a reply channel, because if we have a look at it here, the get function only takes a reply channel, but the getStream function takes a tuple of an aggregate and reply channel. So what we actually need to do here is we need to provide it a new function, a lambda function, that then takes the reply channel. And what we are going to return is the getStream message for a tuple, which is then again the aggregate and the reply channel. And then we can actually use this in here and can say getStream is getStream. All right, so we actually changed our event store and enabled it to actually work with different aggregates and different event streams. Every function or every message in here now is able to cope with different aggregates, which is nice. What is left to do for us now in this video series is only to make our program work again down there. And what I have done for now is that I added a new header to our print event function, so we can have a look at it. And I just added a header in here so that we know which truck, for example, we are talking about. So for which trucks all the events are that we are going to print. And I added a print total history function that is actually printing all the events of all the aggregates for us. So if we have this here, we can say now that we want to print the event for our truck 1 and say truck 1, and we can print the events for truck 2. But for this we actually need some events in there, so we just copy this here and use the truck 2 for this. And then we could use the events for one aggregate, so for one truck, for example, here in our projections. So these are the events for truck 1. And for example, in here we could say that we also want the events for truck 1. So all the projections are running now only for our truck 1, but we can change this to truck 2 at any point. But up here we get all the events for truck 1 and for the other aggregate, which is truck 2. So let's run this. So let's make this a bit bigger here, and then we can run this. And we see that all our tests are running, that we have 4 events for our truck 1 in the history. We have 1 event for our truck 2, which is flavor was not in stock, because I think we used the cell flavor without actually restocking the stock of the truck 2. And we see down here that we can just use our projections for the events of a specific aggregate. So that's it pretty much. We've done it. We have built an event store that is able to actually work with different event streams and that is able to give us back the event stream that we actually want to work with in our system. Great! So we have done it. We have added the possibility to actually work with different aggregates and different event streams in our small event source system. And this pretty much concludes the whole video series. So having a small look back, let's check what we have done or what we have achieved together. So in the beginning, I was talking about event sourcing in general. I tried to introduce the topic to you, and I gave the motivation why I think event sourcing is very important and is a very cool topic, and also why I think that it is important that we're actually doing it on our own. And the reason for this is always that I think that if you want to use frameworks, if you want to use something that someone else did for you, you need to understand the problems that these frameworks provide solutions for. And this is very important. And in my opinion, this is only happening if you're actually trying to implement this on your own. In order to be able to actually implement this on our own, I presented a domain, which was the ice cream truck domain, which is, I think, big enough to actually get something out of it, but small enough not to make things overcomplicated. Then we built our own events, and we built the first version of our own event store. We started to get the information out of our event streams by using projections, Later on, we also implemented some behavior in there, some business logic, made some mistakes, built in some bugs that we had to fix by using BDD style tests. And in the end, in this episode, we even implemented event streams. And that's it. This concludes the video series. From here on, I hope that you got the idea that you can actually do this stuff on your own. So if you have an idea to implement something, if you want to actually do something, ask yourself why. Why do I need this? Do I really need to implement this now? Do I really need to understand this now, or can we postpone it to later and understand something more fundamental now? And of course, from here on, we can go much further. We could actually persist the events because for now they are just in memory. We can implement read models, so we could also persist the projections to be able to query them from a different place. We can go full-blown CQRS and use commands and command handlers for actually doing our stuff instead of event producers. We can build in a much more sophisticated error handling, and so on and so on. So if you actually like this and want to go deeper, you can just try to implement this on your own. Or if you liked my video series, I'd be more than happy. If you have any comments or questions, I'd be more than happy to answer you. And if there is enough interest, I might even do a second series or a second part of this video series where I could go much deeper into these topics. And it's also possible that we could, for example, connect this with an Elmish app on the front end. I think the possibilities are pretty endless. So I want to conclude this video series with the quote that fits pretty well, I think, when we are talking about doing something on our own, understanding why we have to do something and understanding what kind of solutions are there and understanding the problems. So it's a quote of a nice book. It's called The 7 Habits of Highly Effective People. And the quote is, "Go climb a ladder, but make sure the ladder is on the right wall." See you in the future. Have a nice day. Bye bye.